About 60 million years ago, the continental crust making up Eurasia and India began the slow process of collision, giving rise to the Himalayas. But in a new study, researchers discovered that half of this landmass has disappeared from Earth's surface. Through meticulous calculations, the team has determined that this missing crust was actually swallowed by the mantle, a phenomenon which was thought to be nearly impossible at this scale. Geoscientists from the University of Chicago calculated the mass before and after the collision, taking into account each of the many ways it may have been distributed. This involved dating the ages of strata and reconstructions of the past plate positions. While earlier efforts to do this have relied on assumptions and efforts to make the system match up with what we think we already know about how tectonics works, the researchers say they've computed the mass with unprecedented detail. What we found is that half of the mass that was there 60 million years ago is missing from the Earth's surface today, said Michaela Ingalls, a geophysical sciences graduate student who led the project. According to current understanding of tectonics, Earth's surface is made up of a mosaic of roughly a dozen rigid plates in relative motion. These travel atop the upper mantle, and the more buoyant continental crust sits higher than thinner, denser oceanic crust. And while the oceanic crust can slip into the mantle, eventually mixing together, less dense continental crust like that in the Eurasia-India collision was long thought to be unable to do this. Instead, it is believed that continental crust, when pushed to the mantle, will be forced back up like a beach ball in water. The new calculations, however, suggest this is not the case. We're taught in Geology 101 that continental crust is buoyant and can descend into the mantle. Ingalls said, "We really have significant amounts of crust that have disappeared from the crustal reservoir, and the only place that it can go is into the mantle," said David Broley, a professor in geophysical sciences at UChicago, Chicago, who is one of Ingalls' advisors and a collaborator on the project. It used to be thought that the mantle and the crust interacted only in a relatively minor way. This work suggests that, at least in certain circumstances, that's not true. To make their calculations, the researchers used recently revised estimates on plate movements to determine how large each of these plates were when the collision began. Then, they combined more than 20 years' worth of data on the geology of different regions on Earth to understand how thick the crust would have been. By looking at all of the relevant data sets, we've been able to say what the mass of the crust was at the beginning of the collision, Rowley said. This revealed a huge discrepancy in the mass, which the researchers say can only be explained if the missing chunk sank into the mantle. After the collision, the displaced crust could only have behaved in a few ways, the team explains. Some was forced upward, creating the Himalayas, while some was eroded and deposited as massive sedimentary deposits in the oceans, and some squeezed out from the sides, forming Southeast Asia. But accounting for all of these different types of mass loss, we still find that half of the continental crust involved in this collision is missing today, Ingalls said. If we've accounted for all possible solutions at the surface, it means the remaining mass must have been recycled wholesale into the mantle. If this is the case, the researchers say the findings could help to explain some of mysteries that continue to baffle geochemists, including the mixing of continental material with the mantle seen when elements including lead and uranium erupt from the mantle through volcanic activity. While these elements are abundant in continental crust, they are rarely seen in the mantle. The implication of our work is that if we're seeing the India-Asia collision system as an ongoing process over Earth's history, there has been a continuous mixing of the continental crustal elements back into the mantle, said Rowley, and they can then be re-extracted and seen in some of those volcanic materials that come out of the mantle today.